So far, happy to deal with that. We'll start with you.
You do on homework 3, number 7.
Sure.
No.
So homework 3, number 7. Okay. First thing I would start by doing is factoring things, but there's nothing really to factor here, so we can go straight to identifying the LCD. In this case, it's just going to be x times x plus 6. You good with that? So we'll multiply both sides of the denominator. So that's x plus 6 times x plus 1 over x plus 6 plus x times x plus 6 over 1 times 1 over x equals times x plus 6 over 1 times, oops, I want blue, 2x plus 1 over x plus 6. Good so far? That's going to leave me with x times x plus equals x times 2x plus 1. So far, so good? Okay. So I'm going to multiply these things out and combine the like terms. And I'm going to do that all in one step. Is that okay, Lando? All right. Yeah. Why not? Okay. What I'm left with is a quadratic, so I'm going to get everything onto one side so I can solve it. So I'm going to subtract x squared from both, subtract 2x from both sides, and subtract 6 from both sides. So far, so good. Now I could solve that quadratic by the quadratic formula, but I also notice that this one is factorable, and that's the what I'm going to use because it's usually a little bit quicker than the quadratic formula. So the two numbers that multiply to give me -6 and add to give me -1 are -3 and +2. And now I have to go and check those to make sure that neither of them is extraneous. So what I'm going to do is I'm going to plug -3 into each denominator and just make sure that it doesn't give me 0. Well, -3 plus 6 isn't 0, and -3 isn't 0, so I'm good with the -3. I'm sorry, +3. And the same thing with the -2. Again, if I plug it into either place, I don't get 0. So both of those answers are good. And that's all I got. Is that okay there?
Yeah.
Cool. Who's next? Happy to do more. Again, I know we didn't do a lot of examples of this yesterday, so it's okay if you guys have some questions here. Again, not a trivial sheet by any means, specifically homework 3, right? Like some of this got rather complicated. Reese, are you raising your hand? We can do number 9. Is that what you're asking? Yeah, of course. So again, much like number 7, I would start by trying to factor, but there's nothing really to factor there. So I'll go straight to finding my least common denominator. In this case, that would just be x minus 3 times x. You agree with that? Okay. So I'll multiply both sides of my equation by that least common denominator. And we'll write this out, what we have now. Okay, so now we can reduce. I don't know why I wrote plus 5s here in that. And combine like terms. Do that all in my head and not really write that down as a bunch of different steps. Is that okay? All right. So I have negative 3x and a negative, so it's negative 5x. And then a minus 15 x squared. That's a plus 2x and another minus 15. Factoring in this case is going to be, and the factoring is really simple. And 7. And again, to check this, if I go back and I plug in to any of the denominators, neither 0 nor 7 makes the denominator 0. So both of those answers are fine. Does that feel okay, Reese? Cool. Landon?
What do you do if the denominator does equal 0?
You just discard that solution. 0 made the denominator 0, just cross it out and keep just the 7. And if you cross it, then there's just no solution. But it's, you know, it's not it's no big deal. There's nothing more to do. Yeah, no problem. Good question. And that does happen a couple of times, right? I think on, let me think. I don't remember, I think on 2 that happens, and maybe. Yeah, no problem, Groots. All right, so while we're kind of all, Elizabeth is finishing up that, let's talk about what's left to do this chapter. So I have one more lesson to do for this chapter. We're going to do that today. Friday we'll kind of touch some loose ends and questions and start on the review. Next week, I don't see you guys live. Monday is a B day. Tuesday, the juniors take the ACT and nobody else does anything. And then Wednesday and Thursday are synchronous days.
Jeez, that's crazy.
And Friday's no school.
Why?
Well, the parent-teacher conferences are going on. So, I'm going to just leave that synchronous day as additional time to work on the review. I'll have a key for the review up by Friday or something. So the test would be our first day back, Monday even, because I think the Monday of next week is a B day, so it would be the Monday of the following week. And I'll get that in the calendar here this afternoon for you guys. But I just figured giving you a heads up would be a good idea. But that feels like that gives us some time to kind of catch up if you're not good with what's going on, but should give you a chance to do that, right? You guys feel okay?
Yeah.
All right. Well, let's get after it today. This next topic is not too difficult, and I think considerably easier than the things that we've been dealing with so far, so that's good. So this is a graphing topic. So we're going to be talking about graphing simple rational functions. Now, graphing any old rational function can actually be quite difficult and rather time-consuming, but we're not going to focus on the most general situation. We're going to just worry about this one rather narrow situation and call that good for this class. So we're going to be talking about just what are called simple rational functions. I abbreviate that as SRF because just so many letters. So we'll start just by defining what we mean. function can be written less polynomial, a degree 1 polynomial. So basically that's going to look like all simple rational functions have two important key features. The second is a horizontal asymptote. So, to graph a simple rational function, the first thing we do is find the vertical and horizontal asymptote. The v is just x equals h. And the horizontal asymptote is y equals k. If we're in the other form, the vertical asymptote is negative d over c. The horizontal asymptote is a over c. Yes, sir.
That says negative over c.
That's over c, like a fraction. We'll kind of plot the. Then we're going to find 3 points of the vertical asymptote. And then we'll plot those points and draw the graph. So let's do a couple of examples. So the first one we'll look at is y equals 1 over x minus 3 minus 2. So we'll start by finding our vertical and horizontal asymptotes. So remember that the vertical asymptote is x equals h. So in this case, our value for h is so close. Be careful. So notice that the formula has a negative sign in it. So the value for h is always the opposite of what it's going to appear. So it's actually going. And the value for k is negative 2, right? Again, the formula has an addition sign in front of the k, so the k is whatever sign. right? So right? So now I'm going to make my XY table. So I need 3 spaces, and then my vertical asymptote, which in this case is 3, and then 3 more places. Now, vertical asymptote never has a y coordinate associated with it, so I'm just going to kind of color in that space to prevent me from putting anything there. There's no point at that x value. So, and then I'm just going to pick some 3 values before it, so, and then 3 values after. And no reason to be sneaky about it, just pick obvious whole number values is probably going to be the best we can do. So far, so good. And now, once we've chosen these x values, how do we find our y values? We just plug the x into our formula, right? So 2 minus 3 is -1. 1 over -1 is -1. -1 minus 2 is -3. Okay with that idea? Just like we've done before. Again, if you don't trust your arithmetic skills, you can certainly do this on your calculator. I would use the fraction command though. So if I press alpha y equals, I can do 1 over 2 minus 3, and then minus 2, and there we go. So you can do it that way also if you don't trust your arithmetic skills. I trust mine, so I don't really use the calculator, but if you want to, you can use it, and that's why we have it, right? The next one is going to be -2.5, and then we have 3 repeating, or 2 1/3. Yes, sir? Certainly. And if I do these ones, I get -1, -1.5, and then 1.6. Draw my graph now. So 1, 2, 3, 4, 5, 6. 1, 2, 3. I have my vertical asymptote at 3, so I'll just draw like a vertical line, but I'm going to draw it dashed. And it's here, so 0, -2.3, 1, and -2.5, and then 2 and -3. And then I'll connect those. So make sure I put an arrow at the ends of my graph. Oh, come on. And then I'll do the same thing for the other half. So I have 4, -1. 4, -1 points. Parts of your graph like that should always be separate sections. But basically that's all it is. Not a big deal, right? Let's do one more example in the other form. And then we have one other little piece to talk about, and then we're done for this. So let's say we have this problem. So again, A, B, C, and D are right here. My vertical asymptote was -d over C. So that's going to be negative of -3 over 2, or 1.5. And my horizontal asymptote is A over C, which is just 4 over 2, or 2. Cool so far? Right, no big deal, just using some formulas, right? So I'll make my table now. In the middle is my vertical asymptote. But there's 3 points on either side of it. And again, I'm just going to pick whole numbers, tricky about anything, right? So if I plug this in, I have 9 over -1, so that's -9. And that's going to be 5 over -3, so that's like -1.6 repeating. And then I have 1 over -5, so that's -0.5. I'm sorry, -0.2, if not. Okay. Let's see, I plug 2 in, I'm going to have 13 over 1, so 13. Plug 3 in, that's going to be 17 over 6, which is like 5 2/3. And then that's going to be 21 over 5, which is like 4 1/5. And now it's time to go ahead and draw our graph. See, so 1, 2, 3, 4, 5, 6. One too many. And 1, 2, 3, 4 is here at 1.5. And then our horizontal asymptote is here at 2. I have -1 and -0.2. 0 and -1.6. And then 1 and -9. Do that. So I have 2 and oh, I didn't even go near. And then 3 and 5.6. Didn't do enough there either. Estimate. And then 4.2. It's like there. So far, so good. Yeah, not too bad, right? Fairly easy. Talk about with regard to simple rational functions is just domain and range. It's all real numbers except for the vertical asymptote. And the range is going to be all real numbers except for the horizontal asymptote. So if I go back to these previous 2 examples, the most recent example, the domain would be everything except for 1.5. And the range would be everything except for 2. Because those were the values for the vertical and horizontal asymptote respectively. If we went back to our first example, and the range would be except for -2. You feel okay on this? Again, should be a pretty easy to handle topic, especially in comparison to the like heavily algebraic things that we've been doing that required a lot of, well, bookkeeping, really, keeping track of what was going on. This is, I think, a considerably more straightforward. So homework 4 has 6 graphing problems, 3 of each type. So I ask you to identify the vertical and horizontal asymptotes, the domain and range, make and fill in your table, and then draw your graph. And you have 6 of those. Sound good?
Perfect.
Okay. Should be pretty easy to handle. Again, not terribly complicated section. So we'll stop